The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Question number 8 also wants us to determine the theoretical yields for a compound. It says magnesium oxide can be made by heating magnesium metal in the presence of oxygen. The balance equation for the reaction is as follows. So if 2 Mg solid plus O2 gas yields 2 MgO solid. So we get magnesium oxide. It says when 10.1 grams of magnesium, so we start out with 10.1 grams of magnesium, is allowed to react with 10.5 grams of oxygen, 11.9 grams of magnesium oxide is collected. Determine the theoretical yield for MgO. So we want to know what the theoretical yield is. So, the theoretical yield is essentially, if we lived in an ideal world and nothing went wrong in our experiment, everything went completely as we planned, and we got 100% utilization of the magnesium and the oxygen. So that would mean if we used everything 100% effectively, that's what our theoretical yield says. So the first objective to this question is determine what is essentially the limiting reagent. Right now we can see that we have 10.1 grams of magnesium and 10.5 grams of oxygen. So we know that all of the magnesium is going to be used up first. Typically you convert this to moles in order to determine which it is. So magnesium has an atomic mass of, let's get a periodic table here. Magnesium has an atomic mass of 24.31. So the AMU for magnesium is 24.31. So if we have 10.1 grams and we divide it by 24.31, we get 0.415 moles of magnesium. And we could also go through and do the same thing for oxygen, knowing oxygen has a molecular mass of 16, but since it's diatomic it would be 32. And you would get the moles for that. But here, we see that we have 0.415 moles of magnesium. So if we want to find out the theoretical yield, we have to compare the magnesium to the magnesium oxide. Remember, when you have oxygen in the atmosphere too, oxygen is typically in excess. So here, we have to multiply it by our stoichiometric ratio. Remember, unknown over known. Here we have 2 MgO, which is our unknown, compared to our known, which is 2 Mg. So, if we look at that, the ratio 2 to 2 is just going to be 1. The next thing we have to do is we have to know the molecular mass of magnesium oxide. Magnesium, we said, is 24.31, and oxygen is equal to 16.00. So the molecular mass is 16 plus 24.31, 40.31. So we're going to multiply it by 40.31 grams per mole. And if we do that, we get 16.7. And if we look at our answer choices, question number 8, answer choice number 2, gives us our answer of 16.7 grams. So the theoretical yield for question number 8 is 16.7 grams. So what I did is I took how much magnesium I had, 10.1, found out how many moles it had, and then I multiplied that by the molar mass. So this 11.9 grams of magnesium oxide actually has nothing to do with this question. You could solve it the same way. If they asked what was the percent yield, then you would need to find out what this 11.9 was. So once again, the answer is answer choice number 2, 16.7 grams.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.